Hello everyone, my name is Sebastian Gonzalez, and in this video, with the help of some other classmates, we are going to explain you how we solve the following problem using the Hardy-Cross method. Okay, in this part, I'm going to read you the problem, and it says this: the arrangement of the main pipeline of a water distribution system. The water demand of the system is 522 cubic meters per hour, and it is supplied at point A at point I, the most unfavorable for head loss. It is assumed that the water demand in the case of a fire plus the required domestic flow is 204 cubic meters per hour. At other points of intersection, it is estimated that the quantities shown in the figure will be the necessary to satisfy a normal domestic demand. Well, now that I have already read the problem, my classmate David Olarte is going to explain the next part.
The elevation made to the sum of our last digit of AD, and for these reasons our elevation is RAG7. The paper network divided into the four meshes, so the analysis will be carried out separately. The mesh 1, made up of points A, B, D, and A. The mesh 2, up and of points D, B, H, and A. The mesh 3, made up the points A, B, C, and F. The mesh 4, make up the points H, A, F, and A. For each mesh, a series of iterations will carry out while the data the client offers us.
Now my other classmate Sebastian Palma is going to explain this part.
Okay, so we have diameter calculation. After performing the iterations, we will have the necessary data to calculate the diameters using the Hazen-Williams formula, and we took into account that the roughness of commercial steel is 9. The next slide. Here we have the pressure distribution. After finding the diameters and with the elevations that the problem gave us, plus those that were calculated with the ID of each member of the group, we proceed to find the pressure distribution at each point of the mesh.
And for this last part, we got Nicolas Vargas with the conclusions.
Okay, the final conclusion are three. The first is that we can observe the diameter of each of them two pipelines is relation for the losses that suffer each stretch. The second is that we evidence that there are different pressure in each of the nodes, as these are in a different weight. And the last one is that when I do a series of iterations, we can see how decrease the values of the values and some take negative values, and that's all. Thank you very much.
Well, I hope that you all can understand our explanation, and thank you so much for your attention.